Hello, and welcome everyone to the launch of the second edition of the State of Carbon Dioxide Report, or Removal Report, which is a global scientific assessment of where CDR stands today. I'm delighted to be here moderating this event hosted by the University of Oxford's Smith School for Enterprise and Environment. I'm Laura Williams, a climate columnist at Bloomberg. In my 18 months on the Climate Beat, it's been fascinating to watch the discussion and interest around CDR really grow as the sector has gained momentum. We've had some huge newsworthy moments. There's a new world's largest direct air capture facility in Iceland with the switching on of Climeworks Mammoth. There's been key policy developments, such as the EU's carbon removal certification framework and the US Inflation Reduction Act funding. There's no doubt that this is a nascent but rapidly evolving area, and one which is likely to play an important role in our fight against climate change. But, as this report makes clear, there are still substantial gaps to fill. This year's report, written by 50 authors from leading research institutes around the world, is even bigger and even better than last year's, so I urge everyone to take the time to read it in full. It will be available on the website stateofcdr.org at 5:30. But we have some of the authors here today to walk us through the highlights. We'll be hearing from Dr. Steve Smith, Executive Director of Oxford Net Zero and CO2RE at the Oxford Smith School, Dr. Matthew Giddens, Senior Research Scholar at the International Institute for Applied Systems Analysis, Dr. William Lamb, a researcher at the Mercator Research Institute on the Global Commons and Climate Change, Dr. Ingy Johnston, Research Associate at the Smith School, Professor Greg Nemeth, Professor of Public Affairs at the La Follette School of Public Affairs, University of Wisconsin-Madison. You can add your questions throughout using the Q&A function, and we'll be answering those after the presentations. But first to kick us off is Dr. Steve Smith, and I'd like to invite him to take the stage.
Thank you very much, Laura. It's a real pleasure to have you all join us here today and for us to be releasing this new State of CDR report. Some of you will be aware of the first edition, which was released back in January 2023. And you'll know that this initiative comes out of the publicly funded academic research community. So loads of us who are leading this report are really involved in some of the main research programs in carbon dioxide removal internationally at the moment. And we got together towards the start of our research projects, and really we saw a need for an independent and scientific up-to-date assessment of what was happening in this sector. So a lot is happening in carbon dioxide removal. We're seeing rapid developments in funding, in research, in business activity, in policy development, and in the public conversation, general awareness around this stuff. So we're seeing lots of interest, also some concerns in some quarters. So we really thought there was a need to have a source of information which is as impartial and reliable as possible, but also to try and close some gaps in information, because as Laura said, there are still some pretty big questions being asked about CDR that we don't fully have the answer to, and we're trying to close them. So the first edition last year was really a first go and actually a bit of a proof of concept. And this second edition is intended not only as an update, and there'll be a need to keep updating, of course, going forward, but also a significant upgrade. So yes, new and improved. We'll explain that how it's new and improved in the coming slides. But first, I just wanted to give a recap of what we mean when we talk about carbon dioxide removal. Really, a carbon dioxide removal method is something that captures CO2 from the atmosphere and stores it away durably, and it is in additional to natural processes, so it's resulting from a direct human intervention. And that's really important. There are three key parts to that sentence that need to be fulfilled. So we have a first principle that the CO2 needs to come from the atmosphere, second one that it needs to be stored durably, and a third one that it's additional to natural processes. So if we imagine a direct air capture machine that we've built, that's a human intervention, and if that's capturing CO2 from the air and storing it for long time periods, for instance, underground in a geological store, then that fulfills the three principles, that is CDR. If the CO2 is captured from the atmosphere but is not stored durably, for instance, if it's used in a fuel that's combusted and the CO2 enters the atmosphere rapidly, that might be utilization of atmospheric CO2, but that's not CDR. And similarly, if the CO2 doesn't come from the atmosphere, but comes from a fossil carbon store. So often we talk about carbon capture and storage, or CCS, as applied to fossil carbon plants, a coal or a gas power station, for instance. That involves durable storage, but that's not capturing CO2 from the atmosphere. And the third principle about it being in additional to natural processes is really important when we think about the land and the oceans, because Earth's natural sinks in the land and oceans are actually helping us out hugely already. They soak up around 50% of our emissions year on year. And the concept of net zero emissions, which you may have heard of as being important for stabilizing the climate, is actually predicated on those sinks still working and us not double counting them. So that's why it's important that if we are talking about capturing carbon through, for instance, planting more trees, we are adding more trees through a direct human intervention and not just simply avoiding emissions through avoided deforestation and just relying on the natural sinks. So it has to be additional to the sinks we already have, the natural sinks we already have. It's really important to get this definition right, because carbon dioxide removal is the only way really to provide a balance of net zero if we still have residual emissions in the system. And it's the only way that we might possibly get to net negative emissions if we can outweigh any residual emissions or get emissions down to zero and do carbon dioxide removal on top of it. So all of these methods that are shown in these cartoons might be important parts of the portfolio of climate actions, but only the one on the left that meets all three principles, or the one on the right where we use direct air capture machines or we plant more trees, only those count as CDR in these things. But actually, there's a very wide range of methods for doing carbon dioxide removal. In this report, we look at 15 methods in total. These are methods that are all actually happening in some shape or form, at least at the pilot scale, and they're all very different. So it's important to think that there's a really wide range of methods with different characteristics. I'm showing you the first 8 here, and we can see that we've classified them in different ways. So you can classify them according to how they capture the carbon from the atmosphere. Is it through a biological process, such as photosynthesis through a growing tree, or for instance, putting more carbon into soils through plants? Or is it through actually a non-biological process, a geochemical process, chemicals, or Earth's natural mineral weathering cycles? So there's also the way that the carbon ends up, what carbon storage pool is used as the final destination for that captured carbon. It might remain in biological systems, in vegetation, soils, and sediments. It might go into the built environment as durable wood products, or in geological formations through pumped CO2, might go into marine sediments or minerals. So there's a variety of places that we can put the CO2. And that means actually that there are other characteristics in terms of how ready this technology is to deploy. Is it already done at scale, or is it at super small scale, at pilot scale, and needs to go through more cycles, more steps on the technology readiness scale? How big might this technology be able to grow? So what is the mitigation potential of doing these things? And the carbon store is actually crucial for determining how durable that method might be. So different carbon stores have different characteristic timescales associated with how long they hold on to stored carbon. And in the report, to try and sort of make sense of this menagerie of methods, we've done what we did in the first edition and boiled these down into 2 very broad categories. One is what we call conventional CDR. Those are the things which are broadly already deployed. They're not really new technologies, things like planting more trees, using wood in buildings. There's, as you can see, a very broad trade-off between readiness and durability in some sense. And then we look at the more novel technologies, which are generally less ready, but do in the round offer potentially more durable storage. And just to finish off the list, here are the other 7 we look at, and you can see that they involve other carbon storage pools, generally an early stage of readiness. These are more novel technologies. So that's what we mean by CDR. It's important to say this doesn't necessarily capture every single possible CDR method or flavor of method, but we think it captures most of them, certainly the ones that are actually sort of operating today. But over time, we might expect that more methods emerge and maybe better definitions and categories emerge as well. So what's new in the second edition relative to the first edition? Well, first up, of course, we've had another 18 months or so And as I said, this is an area that's moving fast. So we've got newer data, and where possible, we've brought the picture up to the end of 2023 as a year. We've also improved the analysis in several areas. Just to give you a few examples, we have updated the chapter and analysis structure behind the report, really to better reflect what we think is an underpinning model of how technologies and behaviors generally get innovated and scale. So that has meant that we've reorganized some of the analysis. We've introduced a new chapter on the voluntary carbon market, because the source of demand for these things is a really crucial determinant of how rapidly they might scale or not. And that's currently where we see most of the extra demand, and Inji will talk about that in a few minutes. We've improved some of the analytical methods around estimating the current level of CDR, the tracking of patent activity. We have put greater attention to the levels of CDR that are compatible with sustainable development, and that is something that Matt is going to talk about soon. We've also expanded our analysis in some areas. So when we looked at public perceptions in the first edition, we focused on social media data through Twitter and X. We've expanded that now to include looking at print media publications. So some of the more mainstream media, how much coverage carbon removal gets, and where the areas of focus are for print media. All this has been supported by an expanded author team as well. So we've drawn on a wider range of people from different geographies and areas of expertise. And finally, we've got a new data portal. So we hope that when you dive onto the website, stateofcdr.org, you'll find that we have attempted to put as much data as possible out there for you to cut in ways that are useful to you and to use. And that's free and open access. So we hope that's a resource for the wider community. I just want to, on my final slide, walk you through what the key messages are, therefore, from the second edition of the State of CDR. And we have 7 in total, which the speakers coming up will dive into a bit more, but here's the kind of super high-level summary. The first point is that meeting the Paris Agreement's long-term temperature goal requires rapid greenhouse gas emissions reductions and near-term scale-up of carbon dioxide removal. So we see both in pathways. It's not really an either-or situation. And what we find is that the sort of central estimate for the range of carbon dioxide removal in these pathways that fulfill the Paris Agreement, while also meeting sustainable development goals, is in the region of 7 to 9 billion tons of CO2 per year. Now, what's happening now is we see some CDR deployment, albeit at a low level. So we see actually about 2 billion tons per year happening, so a lot lower than that 7 to 9 central range for 2050. Nearly all of that is what we call conventional CDR. So that is through afforestation, reforestation, with a tiny fraction coming from some of the more novel methods. Now, in order to scale up, innovative activity needs to intensify, and we do see evidence of that. We see investment in startups, for instance, has increased from under $0.1 billion in 2019 to around $1.5 billion in 2022. But actually, we see some signs that that might have flattened out recently as well. The fourth point is that to increase CDR innovation and scale up, we need policies that create demand for carbon removals. These things might be developing at early stages, but in order to scale them, they need a long-term and robust source of demand. And there are fairly well-established policies. Governments are already targeting conventional CDR, planting more trees, although it still remains to be seen whether those policies will deliver. Most demand for the novel CDR methods at the moment is coming from voluntary action. It's from companies and other organizations essentially willing to purchase carbon removal credits on the voluntary carbon market. And that's growing, but it's fairly small and it's fairly fragile. Fifth point is that public awareness of CDR has been rising. That's something we won't cover in a huge amount of detail in this presentation, but we have a chapter dedicated to that. We analyze social media and print media, as I said, and we find a 4- to 5-fold increase in CDR coverage over the last few years, but again, showing a possible flattening out just in the last year or so. And another thing that's going to be really important is what we call monitoring, reporting, and verification, or MRV for short, which is actually making sure that we know the carbon dioxide is coming out from the atmosphere and is being stored away, and that we can guarantee that that is leading to net carbon removal. This is really important, and we have a bonus chapter looking at this at the end of our report. We look at actually 102 different protocols that are now in existence, 2/3 of them developed within the voluntary carbon market systems, and 40% of them actually just come online in the last 2 years. So this again is emerging really rapidly. And currently, comparison and oversight of these different protocols is really difficult, and a key challenge is to develop robust and widely accepted approaches. Finally, there continues to be a gap between the amount of CDR in the scenarios, in the pathways that meet the Paris temperature goal, and the amount of CDR that countries are currently pledging to scale up in their national pledges under the international climate regime we have, the UNFCCC. As in the first edition, we quantified this shortfall, and we find a gap of up to around 5.5 billion tons of CO2 removal by the year 2050. That's the gap. And for the first time, we actually quantify how that gap is increasing as a result of our continued failure globally to reduce emissions. So I'm going to hand over to some of the authors now just to dig into more of the details behind those headlines. And first up is Matt Giddon, who is going to talk about current CDR levels and the levels that might be needed in future.
Great, and many thanks, Steve, for the nice introduction. So indeed, I'm going to talk briefly about our assessment of what the current levels of CDR are, and as well what future levels might need to be according to our scenario assessment. Steve has outlined already sort of some of the headline numbers here. As in the first edition, we look at the current levels of deployment of both conventional CDR as well as novel CDR, and the conventional CDR estimate is the gray bar on top. The novel CDR estimate is the colored bar below. The key outcome here is that the amount of novel CDR currently being deployed is dwarfed by the amount of conventional CDR, very small at only approximately 13 megatons or 0.0013 gigatons compared to the approximately 2 or 2.2 gigatons of conventional CDR. What's important to note is that these numbers are different than our first edition, largely because of methodological improvements in our assessment approach. So on the side of conventional CDR, we have continued to work with the latest and best available science together with colleagues in the Global Carbon Project to understand how much net carbon flux, or how much carbon is being removed from the atmosphere based on our model approaches today. Critically, our number in terms of current novel CDR deployment is different for two primary reasons. One is that in the past 2 years, we've seen a relatively large uptick in the amount of removals from biochar, going from 0.2 in 2021 megatons to 0.7. So that's the brown bar on the right. And the second is that some of the largest BECCS plants, which sit in the USA, have had their estimates in terms of the amount of carbon removal revised downward. And so our estimate for BECCS is smaller than last year. Our estimate for biochar is larger. The total amount is approximately the same or similar. So if we go to the next slide. So we also, in our report, we look at what is the level of CDR today, and also what is the level of CDR that is needed to meet multiple global goals. To do this assessment, we look at scenarios of future CDR deployment. And critically, this year, we have improved our analysis by going beyond what was published by the IPCC and AR6. So in edition 1 of our report, we looked at scenarios published in AR6. And those, as you can see from this table, are largely dominated by BECCS as the main CDR method, the main novel CDR method, with a growing number starting to include direct air capture. And in this edition of the report, we include new scenarios published in the literature since AR6, for which there's almost parity between BECCS and direct air capture, and increasingly other novel CDR options, such as enhanced weathering or enhanced rock weathering. If we go to the next slide. So what is critical, or what are we looking at when we're looking at scenarios? So we're looking at the difference between, or we're looking at the evolution of carbon removals, which is shown in this figure with the yellow bars below the zero line, and residual emissions both of CO2 here in purple and other greenhouse gases in pink. And CDR is doing a couple of different things in a given scenario. On the one hand, at around the time of net zero CO2 emissions, CDR is being deployed, as you can see, around 2050. It's being deployed in an increasing amount, and it's used to achieve net zero CO2 emissions, at which point temperature increase approximately halts, and we get to around something like stabilization. It's used to then counterbalance these residual CO2 and other greenhouse gases. That's again the blue and purple bars. And then it's also, if it's continued to be deployed, and also these other residual emissions are continued to decrease, we can achieve net negative emissions and eventually net zero greenhouse gases. And in this net negative and net zero greenhouse gas regime, the best available science tells us that temperatures will then start to decrease again from a peak. But when we look at scenarios, and when we looked at scenarios in the last edition, we looked at all of the scenarios that achieve certain temperature targets below 1.5 degrees, below 2 degrees with a better than 2/3 chance. But we recognize that while that's a valid way of looking at future CDR needs, we're not taking into consideration critical issues around sustainability. And so the next novel aspect that we introduced this year is we do a bespoke sustainability analysis of each one of the scenarios that we're looking at. And in particular, we're looking at the scenarios, we're looking at different thresholds in terms of biodiversity, in terms of population at risk of hunger. So making sure that when we're deploying CDR methods in these scenarios, that we're not also dealing with issues around provision of food and malnutrition. We also look at energy efficiency and energy access, and then finally land and water resource needs. And when we take those together in the next slide, we find that the scenarios that we assess that do meet these different sustainability considerations by 2050 need between 7 to 9 gigatons of total carbon removal as a central estimate. And there's a number of key things as we dig into these numbers in particular. The first is that these more sustainable scenarios are scaling up CDR at a similar pace as the full set in terms of this total number. Noting that scenarios that limit warming to below 1.5 degrees are also scaling up CDR faster. However, even though they scale up at around the same rate and meet the same rate or the same level, the more sustainable scenarios tend to use more conventional CDR on land and less novel CDR compared to the full scenario set where sustainability is not necessarily a consideration. But then also critically, as Steve pointed out at the beginning, while all of these scenarios are scaling up CDR, they're also very strongly reducing current sources of emissions. And the sustainable scenarios that we assess do so even more than the full set. And so what that means is that while they produce or use 7 to 9 gigatons total CDR by 2050, until that time period, until we get to net zero CO2 emissions, they are doing more in terms of the emission reduction space and less in terms of the cumulative CDR space. But it's important to note that these scenario assessments are really providing us different plausible futures, and decisions that we make, decisions that policymakers make, will determine where in that scenario space we lie. And with that, I'll hand over to Greg.
Thanks, Matt. So as Matt showed with the scenarios, we need to be speaking in gigatons or tens of gigatons for CDR to be climate relevant. But we know from previous technologies that we also need to track interim progress when things are so small. And so innovation is really important to scale. And that's why we have a focus on innovation. So in this part of the work, we want thinking about innovation as a sequence of activities with feedbacks. It includes improvement and ultimately widespread adoption. And it leads us to a broad set of indicators that we can track. One of the normative aspects we have from studying CDR are the benefits of a diverse portfolio of approaches to removing CO2 from the atmosphere. And what we can plot here is with each of these indicators on research, on demonstration, on deployment, how diverse, how many different types of CDR approaches and how much they contribute to each of these indicators. And we can see that we do have emerging diversity in some of the indicators of CDR development. We see it in research, in grant funding, in demonstrations, and in patents, but we don't yet see it in current deployment or in national proposals. So going deeper into some of this innovation work, we can look at one of these indicators of innovation, which is patents, meant to represent inventions and early activities. And what we see there are that the patents have actually been declining over the last 10 to 15 years. This is something we see in other areas of climate technology as well, but that they have been diverse. If we compare patents to some other early indicators of innovation, such as grants, so research grants to fund CDR, we can see that grants have been increasing generally, but flat from the latest data that we collected for last year compared to the year before. But publications have been ever increasing. So we see a few different directions for these three indicators: patents declining, grants stable, and publications increasing. On to the next slide, we can look at another indicator of innovation, and that's kind of in the middle between research and actual deployment, which are early plants, demonstrations. We're further along the innovation chain here, and it's where we see some of the most dramatic activity in the last couple of years. We've seen rapid expansion in demonstration projects. The primary locus of this is in the United States, but we also see emerging international activity. The program that is most interesting in the United States is the direct air capture hubs, and that's a between $3 and $4 billion program for 4 projects, each of which is supposed to be about a megaton of removal a year. 2 of them have been selected, 1 has actually been funded, 1's being negotiated, and 2 more are still to be determined. And complementing the US program, we also have Mission Innovation. This is an extension of coordinating research and energy research that was signed alongside the Paris Agreement in 2015, now has a CDR program called the CDR Launchpad. And there the idea is to coordinate plans, to share information. And you can see the plans for demonstration projects over the next 7 or 8 years in different locations with what we like to see in innovation, increasing scale over time. Next slide. Going further along the innovation chain, here is where we look at startup companies. And this is looking at carbon dioxide removal startups. And what we see in our latest information from 2023 is that we're down from the peak in 2022 pretty substantially. We had about $856 million invested in 2023, and that went into 145 CDR startups. The different types of technologies has grown more diverse in the last couple of years, even though the funding itself has declined. And one of the notable items that we've noticed in this information gathering, which really comes from Professor Morgan Edwards and her team, using data from Net Zero Insights. And one of the benefits of that data set is we have all climate tech startups. And we can see that startups that we categorize as carbon dioxide removal account for just over 1% of all climate tech investment in 2023. Next slide. And then going further along, here we have not actual deployment, but plans and announcements from companies about their plans for future deployment. And one of the things that we see is and you can see from this, I'll just mention the scale of this chart here. So we're looking at the next 20, 25 years, but the scale is logarithmic. So we are going from the values we're in today, megatons at best, to the values that Matt talked about, which is tens of gigatons. And we do see, and it's a logarithmic scale to put all those on one chart, we do see over time these ambitious plans that companies have come up with. And if we just sum them very simply and see where we do get to numbers that are in line with some of the scenarios that Matt talked about. These are not plans that have funding behind them. These are not construction projects where there's contracts signed. These are just announcements that companies have made. So we don't put any credibility in terms of how likely these are to happen, but it does show some indication that the industry does understand the scale of the challenge and is making announcements that are commensurate with that scale. But the last thing I'll just say on this slide is that what's missing mostly from this is some set of policies that would justify why you would expect companies to be building 1 gigaton of removal capacity per year in the next 10 to 15 to 20 years. We don't see that policy signal yet, and we think that's a real important lacking area that needs to be changed from a policy perspective. But where we do see demand is in the voluntary carbon market. And so I'll pass it on next to Ingi to start to talk about that.
Fantastic. Thank you, Greg. And yeah, just to follow on for what Greg was saying, so demand remains absolutely critical to scaling CDR, and demand equals financing in this context to actually pay for the deployment of these technologies, whether conventional or novel. And funding by the voluntary carbon market has played a significant role in building this demand, particularly for the novel CDR. And we're really excited that aspects of this relationship have been explored in this brand new chapter on the VCM, as Steve mentioned. But it's first important to just define what we mean by the voluntary carbon market. So in this report, we define it quite broadly to include both the traditional registry-based markets as well as the newer kind of bilateral deals that we're seeing, particularly in novel CDR, such as offtake agreements. And it's worth just starting with the big picture that the VCM encompasses a wide range of emissions avoidance and reduction activities alongside carbon removal. But that active VCM projects with the potential to generate CDR are indeed found across the world, as this figure presents. But in 2023, CDR credits accounted for less than 10% of the total credits sold on the VCM. And when we take a bit more granular of a view, there are also some central differences between conventional and novel CDR as it's treated on the VCM. So for starters, conventional CDR is predominantly transacted via the traditional registry-based markets, whereas novel CDR tends to be bilateral transactions. And so this can mean that apples to apples comparison between the two can also be quite difficult, because conventional CDR tends to be ex post issuances and retirements of carbon credits. So after the project has occurred and been measured, reported and verified, whereas novel CDR tends to be ex ante and thus recorded in kind of deliveries and purchases. And so when taking a look at how these two fare via the VCM, it's interesting to just note from the outset that conventional CDR financing via the VCM does remain limited, and indeed credits issued for afforestation and reforestation represented less than 1% of the total afforestation and reforestation efforts that occurred in 2023. And then on the same hand, that novel CDR has received significant funding from the VCM, and we saw purchases actually grow 7-fold between 2022 and 2023. So we can already see some really important differences. Next slide, please. Actually, no, this is the right one. Fantastic. So how does CDR actually originate on the VCM? Well, it's worth saying that generating CDR begins with project developers who follow a methodology to monitor and quantify their deployment of CDR as well. And it's really important to note that, as Steve mentioned, MRV has become a key focus in this chapter. And why that is because it is absolutely fundamental to even evidencing that CDR is occurring today. And what's interesting to note is that, as you can see, this figure presents the growth in MRV protocols for CDR. And as Steve mentioned, several of these are only documented from 2022 onwards, and 65% of these have actually been developed from the voluntary carbon market. But the significant variation in the numbers of these protocols means that there's a need to bring consistency especially in light of the fact that some of these methodologies are proprietary, so private. We can't see what's in there. And also, it's really critical that there are necessary safeguards, especially when we're talking about CDR. And some of these examples of these issues include durability. So how long may the carbon be stored for? And are there processes to manage reversals? Double counting. Could it be possible that this unit of CDR is counted by both the project developer and the purchaser? Quantification, how is removal actually quantified on the ground, and is the complete life cycle actually considered as part of this? And also critically, additionality. So would the CDR have otherwise occurred if this credit had not gone through? But then beyond these quality aspects of MRV, actually determining how much CDR is facilitated by the VCM can also be tricky, because fundamentally on a methodology basis, sometimes removals and avoided emissions are conflated. And this is despite the fact that removing 1 ton of the atmosphere has a very different climate impact than preventing that emission of 1 ton of CO2. So in this report, we've dealt with this through providing the categories of mixed, mainly removals, and mixed, mainly avoidance, as the slide reveals. And looking at it as a whole in the VCM, we can see that the categories of emission reduction, avoidance, and mixed avoidance still dominate CDR in absolute terms, in terms of the number of credits issued and retired across both 2022 and 2023. It's also important to note that, especially when comparing them on the same figure, that it's often not the same credits issued and retired in the same year. In fact, we can see retirements of credits that are generated from projects as far back as the early 2000s. So it's really important to note that difference. Next slide, please. Fantastic. So turning to the levels of conventional and novel CDR that we found in the chapter. As has already been mentioned, the VCM currently does fund more conventional CDR than novel CDR in absolute terms, but it is only that latter category of novel CDR that is showing signs of significant growth year on year. And as previously mentioned, it's important also when considering this data that, again, the way that these two methods are deployed on the VCM are very different. So for conventional CDR, we are often looking at ex post issuances, whereas novel, it's ex ante. And so that explains some of the different terminology that it's important to know here on the slide as well as in the report. But what these two figures demonstrate is that on the conventional market, we do have issuances clearly outstripping demand for retirements, and this results in a surplus of credits. Whereas we see the opposite is true for novel CDR, where we see significant purchases but limited actual deliveries. And the mean average delivery time across all the variety of technologies is about 3 years. And so that evidence says that need for a different financing approach. But the figure also shows differences in scale. So we've seen some shrinking issuances and fairly stable retirements for conventional CDR, but it's a vastly different picture for novel CDR, particularly due to these large offtake agreements that we can see really do accelerate the demand. But it's still important to note that these are different scales in these two figures. Next slide, please. Fantastic. So to kind of summarize the chapter, the VCM has played a really important role in financing CDR, but it's clear that more long-term signals are needed. And so we've already seen the kind of current state of play of 2022 and 2023, but it's important to kind of zoom out and consider this broader landscape in terms of where we may be heading in the future. And as we know, the VCM is largely unregulated and has been subject to a significant degree of criticism and scandal, such as the Guardian article that most people will be familiar with that estimates perhaps over 90% of rainforest credits could be worthless. And there's been some more recent systematic reviews of different projects, and that reveals that the VCM has struggled with some very systematic overcrediting issues, and it's pervasive across a variety of market categories. But looking at particularly removals within that, it's also prompted some reform, for instance, on the methodologies and protocols level, in terms of separating out how much in a given project is happening due to avoidance and how much is happening due to removals. And we've also seen various organizations on both the supply and demand side of the VCM providing guidance on credibility. For example, the Integrity Council for the Voluntary Carbon Markets, Core Carbon Principles. But really, this VCM reform alone does not provide a sufficient demand signal to scale CDR to the levels needed, because it still remains voluntary. And there's a really considerable price differential between CDR and these other forms of carbon credits. For instance, conventional CDR credits are 3 times more expensive than emissions reductions, and novel ones are 100 times more. So what does this mean for the future? Well, it means that there has to be some really careful integration of CDR into some bigger demand mechanisms. For instance, domestic compliance markets like emissions trading schemes, as well as international compliance markets, including Article 6. But then within this picture, we still see this role for the VCM as a kind of ongoing catalyst in a form of a niche market to really test the greatest viability of these very diverse novel CDR techniques to really address the growing CDR gap that we have now and into the future. And to discuss this a bit further, I'll now hand over to Dr. Lam. Thank you.
Thank you, Ingi. So in addition to the VCM, country plans and proposals have an important role in scaling up CDR. And in this latest edition of the report, we updated our previous analysis of the NDCs, the nationally determined contributions, the long-term strategies, as well as other documents that countries are submitting to the UNFCCC as part of their commitments to the Paris Agreement. And so these documents contain some information that we can extract, giving us a sense of how much CDR they plan to scale in order to reach net zero. So our new analysis shows that up to about 2.6 gigatons of CO2 per year of conventional CDR may be deployed by 2030. Remember that that's not very much more than the current level, which is 2.2. And by 2050, we might see up to 4.4 gigatons CO2 per year of conventional and novel CDR methods if the most ambitious proposals being currently developed by countries are put into place. So we do find, however, that many national documents and scenarios lack transparency. And so we have to make some assumptions, particularly that countries without proposals that have still to submit or develop their plans will sustain their current levels of conventional CDR. And generally, we see a very important need for countries to be more clear and transparent about how they actually plan to reach net zero. Next slide, please. So how do these country proposals compare to levels in scenarios? Well, that depends on which scenario we follow. As Matt pointed out earlier, there's a range of approximately 7 to 9 gigatons of removals that we need to get to in 2050. And from that, we chose to compare our national proposals to 3 specific scenarios. All of these scenarios have very ambitious near-term emissions reductions. They meet the sustainability criteria we discussed earlier, and they have different types and levels of CDR scaling. So one of these scenarios sits well below the 7 to 9 range. That's reaching about 4.8 gigatons in 2050. That's a low demand scenario that achieves its targets without any contribution from novel CDR. The other scenarios reach 7.5 to 9.8 gigatons of CDR in 2050, and they do so respectively with a higher contribution from conventional CDR and novel CDR. Next slide, please. So if we compare these proposals or country proposals to these scenarios, we find a gap, and that gap is hundreds of megatons to multiple gigatons in 2030 and 2050, depending on which scenario we compare to. It should be noted that here on the right-hand side of this figure, you can see that proposals of 4.4 gigatons in 2050, put forward by the most ambitious scenarios in countries' long-term strategies, they come close to this no novel scenario, right? And that suggests that if they're fully implemented and if these are supported by rapid emissions reductions laid out in that scenario, then the CDR gap could be minimized. Otherwise, if we're aiming for one of these other scenarios, then we have much more work to do to fill the CDR gap. Next slide. Now, it's important to be clear-eyed about the challenge, however. All 3 of the scenarios that we use for the gap calculation do assume that emissions reductions already happened. This is a general problem with the scenario assessment literature because it takes time to produce these and then assess them and so forth. And unfortunately, the opposite is true, right? Emissions continue to grow since 2020. And just the fact that we failed to make these emissions reductions since 2020 means that we already need to compensate that with up to 1.5 gigatons CO2 per year of additional mitigation effort in 2050. And since a portion of that mitigation effort could be met with additional CDR, could also be met with faster reductions, we think the CDR gap may be larger than we assess here. Next slide, please. So to summarize what we talked about today, current carbon removal sums to about 2.2 gigatons per year. Countries are proposing up to 4.4 in 2050. More sustainable scenarios deploy between 7 and 9 in 2050. But an extremely ambitious scenario with no novel CDR deploys about 4.8. And so whichever way we look at it, we think there's a CDR gap, and we need to fill that gap with policy support, with innovation, and with markets aligned to rigorous MRV. Next slide, please. But in addition, it's really important that we remember and think about those numbers I just talked about. Global net greenhouse gas emissions were 55 gigatons of CO2 equivalents per year in 2022. And emissions accumulate in the atmosphere. So the longer we wait to implement reductions, the more difficult it will be to meet the Paris temperature goal. And in terms of impacts, every 1/10 of a degree of warming really matters. So it's important that we finish on this note that a failure to strongly reduce emissions from fossil fuels and from deforestation will put the Paris temperature goal out of reach, even if we have strong action on carbon removal. Next slide, please. So I'd like to extend our thanks to a much larger author team this year, including the authors here, the co-authors. Next slide. As well as our project and portal team, a large number of reviewers, and especially to Sarah Singleton for guiding us through the whole process. Next slide. And of course, we depended very much on funding from these different supporters and our own lead institutions. Next slide. We would like the state of CDR to be a continuous effort that we can update in later years. And you can already go and download the latest report at the website here and continue the conversation on social media. Thank you.
Great, thank you so much, everybody. So while we're just waiting for some more audience questions to be entered into the Q&A function, and don't forget to upvote questions that you want to see answered, I'm going to ask some of my own questions. And I'm going to start with, to be a bit of a devil's advocate. If novel CDR accounts for only 0.1% of CDR happening in the world right now, why do we need it? Should we not focus on those conventional methods that we already know how to deploy at scale? And I'm not quite sure who wants to lead this, perhaps Matt, if he's on screen.
Sure, I'm happy to take a first stab at that. So I think our assessment is very clear on a couple of points. One is that the key near-term mitigation activity needs to be reducing current sources of emissions, while at the same time increasing and scaling up CDR. I think it's fair to say that that there will be no silver bullet to any of these approaches, and that it's effectively a no regret strategy to pursue multiple approaches to removing carbon from the atmosphere. And I think it's also critical to say that there are limits to what we can do with conventional CDR, and those limits are based both in terms of just the basic available land area, but also there are strong sustainability considerations in terms of how much land area we want to use for CDR. And so for those reasons, I think it's important that we also are focusing on scaling up novel CDR. Now, critically, not all of the scenarios we assess use novel CDR. Will highlighted one such scenario. But the vast majority do, because there are cost-effective trade-offs with other issues around very hard to abate sectors like aviation and shipping and these sorts of things. But fundamentally, as I said myself, where we are, what decisions we make today will decide basically how much novel CDR we will need in the future. But there's also decisions that are outside of our hands. So all of the scenarios that we've been looking at and have been assessing are assuming that we have, for example, the climate response to cumulative emissions approximately right? So there's a wide range in terms of what the climate itself will respond to in terms of global mean temperature rise, and if just as a physical response, and if we happen to be on the wrong side of that distribution, just in terms of how the climate is responding to emissions we're putting into the atmosphere, we will need more CDR than we expect already to actually get to stay within the temperature goals that we're laying out well below 2 degrees. So I think that there are a wide variety of reasons as to why we should be pursuing novel CDR at scale. Whether or not we need to use it at the tens of gigaton scale that we're talking about is fundamentally will come down to policy and technology choices that we'll make as we move forward.
Great, thank you. And which regions and nations are emerging as key CDR players, in research, policy, and deployment? Greg, I don't know if you would like to take this.
Yeah, I can mention a couple of things. So on some of the innovation indicators, so we see a lot of research funding happening in Canada, the US, and the EU. On a second indicator, patenting, so new inventions, we see a lot of new inventions happening in China. And on a third indicator, on demonstration projects, we see some of the largest demonstration projects happening in the US, but with mission innovation, we're starting to see a more diverse set of countries getting involved in these kind of medium scale technologies. And then, there are other countries that have potentials that could be playing larger roles that haven't come onto our radar yet in terms of being big enough to do it, but that doesn't mean that there isn't capacity, and doesn't mean that there isn't smaller activities that are starting to get to scale that we may see in the next time we do this report, for example.
Great. Does anybody else want to come in on that, or shall I move on to the next question? I can move on to the next question. So how has the awareness and understanding of CDR changed in the last year or two, both by policymakers and the public? Steve, do you want to start on that?
Yeah, I can have a go from the public point of view, because as I mentioned, we have a whole chapter on this, but we didn't have the opportunity to dive into it for time's sake. But I would recommend that, and the lead authors, the authors there have done a great job. So we look at two types of information broadly, actually. One is what's called elicited information, which is where researchers have actually gone out and asked people what their views are on CDR, what do they think about it, what's their level of awareness, and kind of proactively try to get the views and dig under why they think what they think and why they know what they know. But the other thing is unelicited information, which is where people broadcast. So this is where the social media and print media comes in, where people choose to put their views out into the wider world. And we're seeing awareness increasing a lot. So as I said, across actually both print media and social media, we're seeing a similar sort of 4 to 5-fold increase in volume of comments being made or articles being written. You might think that social media is growing fast, so you'd expect growth there, but actually you see a similar sort of growth in print media. But in both cases, actually, in the last year or so, we've seen a sort of flattening out. So compared to our snapshot in the first edition of State of CDR, we're seeing broadly similar volume of tweets and broadly similar sentiments on similar CDR methods. So not much change in the last year. Interestingly, we see in print media particularly, there's still a lot of conflation between carbon dioxide removal, carbon offsetting, carbon capture and storage. So those are some of the things we're kind of at pains to spell out in this presentation. Sometimes it's useful to talk about those things together where they share common features, but they do have important differences. And so I think there's still an awareness piece around sort of getting people to understand better what carbon removal is. And actually, the chapter we've written surveys some of the emerging sort of good practice about how to communicate CDR well, because that's something that's coming up in the literature. I would say that all the public awareness work we've done in the State of CDR so far has focused on the English language. which is not just English language countries, but it's English language outputs from other countries. So we do have that kind of bias, I suppose. It would be nice to expand that in future. Great.
Well, thank you so much. We're going to move on to some audience questions now. And the first one I think would be one for Inji from Simon. What is the panel's view on the evolution of CDR offtake? Currently, Microsoft is the only offtaker that is entering contracts that can fund large-scale projects. Over-reliance on one buyer naturally puts the sector at risk.
Absolutely. Thank you so much for the question. And I think it's a really pertinent one, because as we saw from the presentation on the chapter, novel CDR really does depend on a lot of these bilateral transactions. It does not currently operate to a great degree via the traditional kind of voluntary carbon market as we know it. And offtake agreements are a big part of that. So I would say that while Microsoft has been the biggest individual purchaser, and in particular in reference to the Ørsted developments over in Denmark, I think it's really interesting to kind of think that it's not just an individual purchase, that we are also seeing, and indeed some of the original kind of advanced market commitments from the likes of Frontier, and these kind of aggregate demand from a number of diverse purchases. And so just as they kind of seek to provide a diversified pool of funding for the project developer, they also seek to minimize that risk on relying on any one particular buyer. And I will also say we're also seeing some alternative models of funding, for example, the Milky Way funding, which doesn't depend on then in delivery of an offtake agreement in terms of credits, but it still provides that funding and again aggregates demand from a wide number of interested investors. So I think we're seeing increasing diversification of funding streams, and that's really a reflection of increasing sophistication of corporate strategies. And we can get into that a little bit later if appropriate, but really that is talking about this transition to what net zero aligned offsetting could look like. And so I'd also indicate our principles there, which do also illustrate the power of advanced market commitments in this transition. Thanks.
Great, thank you. Next question is, could you speak more to the needs from policymakers to support the development of CDR? Potentially that is one for Greg.
Yeah, maybe try to interpret a little bit. I guess, maybe I'll just say broadly what we found in the report, and that really is in terms of policymakers. We need much larger amounts of CDR than we have today, and it's well beyond what the voluntary market could ever support to reach the types of levels that Matt described or to fill the gap that Will described. And so part of the things that we see are important are continuing support for some of these intermediate innovation activities, like funding research, like funding demonstrations, like supporting nascent markets. That's one thing. Second, critical to policy is monitoring, reporting, and verification. We might think of that as an accounting mechanism or something that's important for life cycle analysis, but it's also crucial for policy, and it's crucial for transactions, and it's crucial for the social license of CDR in the future. And so that's something as well. And then maybe I'll just leave it at that the social license is absolutely crucial as well. This needs to be seen as something that's helpful for the climate. And if it's seen as something that is being sidelined for private interests or for particular corporations that may not have intentions for it to contribute to filling the gap or to addressing the Paris Agreement, then it loses its social license. And that's important. And there's a way that policy can play in that as well. And then beyond that, there's different policy instruments that'll be important, but that's really beyond the scope of what we've looked at so far.
Great, thank you, Red. Really, really interesting point on the social license there. Next question is a kind of, I think, an MRV question. Is there any reliable life cycle analysis available for one or some of the 15 CDR methods? So how much CO2 will be emitted in order to store how much CO2? Big one for Steve.
Well, yeah, I can have a go at that. I mean, this is one of the big issues that we're pointing to in the report. So these monitoring, reporting, and verification protocols that Inji pointed to are in large part trying to assess and take into account at least some of the life cycle aspects of doing these things, because quite often there are emissions involved at some point of the life cycle. So if you're driving a tractor to plant seeds, or if you are using energy to run a machine or to crush rocks, that can involve emissions. And that means you need to consider the whole life cycle to work out what the overall value of the method is. So one of the key issues is the fact that we're seeing this proliferation of different methods that aren't all necessarily fully consistent, although we see a lot of them share common roots in terms of where the analysis comes from. And that's a challenge. But we're also seeing some encouraging efforts. So we have seen that some novel CDR methods and some novel CDR companies have actually taken the time to publish information about their methods in the peer-reviewed literature. So for some of the direct air capture approaches, for instance, papers have been published in peer-reviewed journals where they've been checked by experts, and they include a life cycle analysis for the method. That gives some level of surety. And also another interesting thing that we've seen develop in the last year is the IPCC, the Intergovernmental Panel on Climate Change, is saying that one thing it wants to do over the next few years is write up a methodology report for how different carbon dioxide removal methods could be reported in national inventories. And I think that's an opportunity to actually work on some of these knotty issues about how you measure this stuff robustly and make sure that if emissions are popping up or there are other life cycle issues in doing the process, they are captured in some way in the way in which countries are reporting their progress internationally.
Great, thank you. We've got a couple of related questions. One about marine-based CDR, kind of making the point that marine-based CDR does not directly capture CO2 from the atmosphere. It captures CO2 from seawater, which then indirectly contributes to the take-up of atmospheric CO2. And one related to biochar, again, kind of making a similar point about biochar does not remove CO2 from the atmosphere. It is just the storage. Why is it still considered CDR? And I don't know whether we want to kind of just tap into the definitions again, and that is one for Steve.
I can have a go at that. Yeah, others might want to come in. This is a good question and a tricky area. I think personally it's very important to distinguish between considering the individual locations, points in space and time where CO2 is actually taken up and when it might be re-released back into the atmosphere, and the concept of a CDR method as a whole, end-to-end, because different parts of the CDR method can occur at different times and in different places. So in the case of biochar, there's some form of biomass which has taken that CO2 up out of the atmosphere. So the atmospheric capture part happens in a plant or a tree that's grown. The atmospheric capture does not happen when you convert that to biochar. But what you're doing when you convert to biochar is you're hopefully making it a more durable store of carbon. So especially if you've just got an annual crop or an agricultural waste, which would have grown and probably otherwise the CO2 would have oxidized, it would have decayed or been burned, and that same year the CO2 would have gone back into the atmosphere. You're storing that carbon durably as biochar. So the end-to-end process is biochar production and putting it somewhere. But of course, you have to kind of watch the ball under the cup. The time when the CO2 comes out of the atmosphere is when the biomass is grown. If you're not turning that into biochar, that CO2 probably goes back into the atmosphere. So you're, in a sense, avoiding that emission by making biochar. But I think it is reasonable to call biochar an end-to-end CDR method, because that is a human intervention which has taken CO2 from the atmosphere and put it into a durable store. Similarly, for oceans, yes, a lot of the interventions in oceans are where you are doing something to the ocean to mean that the ocean then subsequently takes more CO2 out of the atmosphere. So that may not happen immediately at the point where the human intervention occurs, but were it not for that human intervention, that additional CO2 would not have been taken up. So it is very tricky. I think one of the things, this ties back to the life cycle analysis question, is we need to be super clear on when and where the CO2s come out of the atmosphere, and we need to track if it ever leaks out in the future and when and where that happens. But I think, using the definition of CDR, which I set out at the start and actually is aligned to how the IPCC talks about CDR, does mean that we can talk about some of these methods that have multiple stages as still being human interventions that capture CO2 and store it durably.
Does anybody else want to come in on that, or I'll move on? I will move on. One question from Mike. This is all excellent background content, which should be really valuable to inform SBTi on their upcoming revisions to the net zero standards. I'd be grateful if you could offer views on what you feel SBTI should be doing on removals to deliver the necessary scale up of CDR this work signals. Perhaps one for Inji.
Yeah, absolutely. Thank you for the question. And I would just highlight that SBTI is kind of one of many live governance processes that are actively kind of considering how and to what extent to work in guidance on removals, and particularly scaling them. And I would say, I guess the one aspect of this that is a lot more kind of timely is this broader shift that we're seeing in the VCM towards, or potentially from compensation claims towards contribution claims. And one thing that we did see in the release, SBTI's recent release of the kind of beyond value chain mitigation framing, is that there was this clear disconnect between how one may go to the levels of especially more durable CDR needed to neutralize your residual emissions by your net zero target date, and where we are today. So I think much more has to be established to provide that pathway and provide that glide path. And that's not just for the organization relying on it to make and fulfill their net zero claim, but also very crucially for the project developer to even develop that project so that the credit will be available to neutralize that emission by that net year. So yeah, I just say that there definitely needs to be much more thought on this. And I would say, but SBTI is not alone in this. So, you know, there's the core carbon principles as well as another example, as is Article 6. A lot of rules are being negotiated right now. And if those parameters aren't set up correctly to really grapple with the complexity of what carbon removal is and what it's not, and particularly to manage the diversity of carbon removal in terms of durability, in terms of the types and approaches, yeah, we need a much more sophisticated strategy across the board, and we need joined up guidance, because as SBTI functionally governs net zero claims for a wide range of companies that are the climate leaders of today. And so it's fundamentally comes back to that demand. So, you know, we should be signaling to these entities that we have to build the carbon removal prospects for tomorrow, but we have to start doing that today. And Microsoft has been a great example of that, but much more is needed. It should not be viewed as a luxury. It should be viewed as a necessary investment today. That's the question.
I think Will wanted to come in.
Yeah, I would just say something about the flip side of that. So SBTI as a corporate standard setter could also have an important role to talk about residual emissions and elaborate a bit more to companies what portions of emissions, what activities should be compensated by CDR. So we shouldn't be compensating everything. We shouldn't be compensating all types of activities, but really only those activities which we think will be very, very difficult, could potentially serve a socially useful function, like food production, like certain mobility needs and things like this. And the importance of that, of course, lies in the fact that we want to build confidence in net zero standards. And one way of building confidence is to ensure that the MRV is right. And another way is to ensure that we're not compensating activities that could easily be part of our emissions reduction portfolio with CO2 removals. Yeah.
Great, thank you. Do you think, one question from Martin, do you think that direct air capture can be scaled up to the gigaton CO2 level, given the huge amounts of air that must be processed to reach this level and the demands for energy and water that these systems require as well as the need to transport the CO2 from where it is captured to durable storage? Obviously, it is a challenging process. Does anybody want to tackle that, Matt? Yes.
Yeah, I can give a first cut. So I think that it will be very important where direct air capture facilities are sited for many of the reasons that were laid out here. I think it makes a lot of sense. I mean, so one thing that's critical to understand is that because these will all be new facilities, they will be able to be sited in specific locations that make sense, for example, from a storage perspective, to minimize the transmission and distribution infrastructure that's needed, which is not the case for example, existing fossil and biomass facilities for which that transmission distribution infrastructure needs to be built out. The other thing to be aware of, I mean, we talked about this a little bit with the life cycle analysis, is that it's crucial what kind of energy is being used to run these facilities, because their ultimate goal at the end of the day is to remove CO2 from the atmosphere. And so running them with fossil-based energy sources will reduce and potentially significantly reduce their efficacy and actually on net in a life cycle analysis system to actually remove that system, to remove that carbon from the atmosphere. And then finally, in terms of resources, I think that this is a big consideration. So just to throw a few numbers out there, the Carbfix site in Iceland needs 20 tons of water for every 1 ton of carbon dioxide it removes. So it puts 20 tons of water underneath the ground as well. And if these technologies can move more towards using seawater as a medium to actually inject carbon underground, that would go a long way to making them more sustainable from a resource perspective. But the questioner is very right. These are all things that need to be considered when siting these plants. And I'll hand it over to Steve, I guess.
Yeah, I mean, at a high level, the estimates from the IPCC and the ones that we use suggest that DAC could be very scalable. We don't really know what the upper limit is. And I think one of the really positive stories is that this is an area where there's a lot of exciting innovation. So lots of people are looking at different configurations of how to do DAC, and the kind of improvements that Matt is touching on and others, I think people are starting to look at. But for me, this so I think DAC is something that people are scaling and it is worth pursuing. But for me, this underlines the importance of the portfolio point, because if we're relying on DAC specifically and DACs, so DAC plus storage to scale to the gigaton scale within a few decades, that's putting a lot of eggs in one basket. And actually, in some ways, DACs is almost the last technology you do. You are expending energy specifically with the express purpose of cleansing CO2 from the atmosphere once it's already got well mixed. Cutting emissions is way more sensible, but also some of the CDR methods have other benefits, and you might not do purely for the carbon removal. This is why biochar is proving popular at quite small scales. So, you know, I think this comes back to DAC is a technology worth pursuing, but it's really important to pursue a bunch of other technologies which have other characteristics, might have other attractions, different risk sets, and might be more appropriate in some situations. So it's part of a portfolio.
Great, thank you. Yeah, really important points, a portfolio of options, just like with renewables. The next question I have here is, do you think any country or government has yet come up with a reasonable policy strategy for CDR, and can good practice be identified? I think Greg would be the one to take that.
Yeah, I mean, starting with I'll go through the innovation chain. If you look early on, the EU, Canada, and the US are doing something pretty good about funding early research. Second stage, in terms of inventions, China's doing something in terms of patenting so many technologies and expanding what they've been doing in terms of invention. So there's something to learn there. In terms of demonstrations, further along, we're seeing the US leading the way with these large-scale projects, the DAC hubs, and then Mission Innovation International Coalition supporting many different projects in multiple countries. And so those are all models to look at. The place where I think the next area is to look at is which countries have sources of demand that governments are creating. And it could be through a market, it could be through regulation, it could through some kind of trading system. But that's where we're really missing this combination of reducing risk, of creating stable policies, of including monitoring, reporting, and verification, and crucially, just creating expectations for the future that the markets for removals will be large and growing, and thus will catalyze investments and all the other things that need to happen, including things like sustainability, pipelines, dealing with ancillary benefits, dealing with side effects. All of those things have to happen. And so that's where we don't actually have really good models. And one of the things that we do on this team separately is look at other technologies and other areas where we have seen markets get created from very little that do incent demand. And so I think in terms of the market signals, that's where we have to probably look at other technologies rather than role model countries, because we don't have those yet.
Great, thank you. I've got a question from the YouTube stream from Sally. What is the most important way that the climate research community interacting with the policy community can do to support the scaling up of CDR? I think that's a question that you all could answer, but I don't know who would like to start us off.
I mean, I can have a go. Partly, I guess that's what we are trying to do in our limited way through this report. So I think the academic community has a responsibility to generate new knowledge that is both kind of new and interesting for its own sake, for exploration, but also new knowledge that is socially useful. And part of our motivation in providing this report is that we kind of saw a gap in bringing together the emerging knowledge around this sector, which is gaining interest and could well be an important part of the strategy for climate action. So I think kind of bringing together and trying to communicate clearly and in a way that is as impartial as possible to decision makers is a key part of what we do and what we're interested in doing. But it was interesting that the kind of part of that question was in order to scale CDR. And I think we do see that that has an important role to play. But I think our bigger role is try to get the climate fixed and in a way that is good for the natural environment and for people. So we see CDR as important, but one of the reasons why we specifically pulled out a scenario of very low CDR was because we want to try and point out to decision makers, policymakers, and other decision makers more broadly that there's a set of options at stake. So the choices we make have consequences, and I think part of our role as academics is to point out the bounds that the physical system provides, but then the choices within those and the different implications. And we don't get to make the choices ourselves, which is maybe a blessing, maybe a curse. But I think that's a key part of our role.
Great, thank you. And, related to that, I wanted to ask, what can we do or what needs to happen to make sure that deployment of CDR doesn't slow down or hinder that, crucial climate mitigation in terms of emissions reductions and climate adaptation? Maybe Will would like to take this one.
Yeah, I mean, I think the most important thing is that countries start to develop comprehensive and ambitious approaches to climate policy. And so that comprehensive approach should include basically targets and instruments to cut emissions in every sector: the power sector, industry, transport, buildings, agriculture, land use, waste. We should be making efforts in all of these areas. And ideally, we should aim to get emissions as low as possible, as quick as possible in those sectors. And we might also consider keeping target setting related to emissions and removals separate so that they don't interfere with one another. And if these kind of broad conditions are in place, I think we can start to address some of the risks that CDR would hinder climate mitigation or adaptation, at least at a kind of policy level. I think there's a different conversation to be had about, the private sector. There, it might be important to start to tackle disinformation and false claims, the notion that we can already get our hands on climate neutral products and services. I think that should be critically challenged. And so there's real work to do there around consumer information laws. Yeah. Great,
thank you. Question again from Martin. How concerned should we be about declines in the carbon absorption capacity of the oceans and land and the release of long sequestered carbon as a result of climate change? I don't know who would like to take this. Matt.
Yeah, I can take a first stab. So there's a couple of facets to our response to this. So I mean, on the one hand, just in general, I think it's important that the people working in this space are aware that this phenomenon is happening, that our ocean and our natural sinks on land are becoming less effective generally at storing carbon. At the same time, many of these processes are captured in the sort of large scale Earth system models that that are used to sort of give us that are assessed by the IPCC and then are used in the kind of scenarios that we presented here in terms of understanding where we're going in terms of temperature space. But finally, I think at the same time, there are still large uncertainties here. And this is, I think it's important to recognize that we're generally shooting for a given goal, but there are large physical uncertainties, there are large political, techno-economic uncertainties about how we get there. And so again, a precautionary approach, I think, is warranted and is also what is built into the Paris Agreement. Yeah, and I'll stop there.
Yeah, exactly. Precautionary approach. So we don't want to poke the climate with sticks more than we really ought to, because we end up in a space that human civilization has not really experienced before. We're already kind of leaving that space. And there are significant uncertainties there, and those uncertainties might not turn out to be our friends. Another point I just wanted to add to Matt's very good point is, one thing we know is that healthy and intact ecosystems are more resilient to a shifting climate, and fragmented and broken ones are less resilient. So part of the kind of additional benefit of protecting our existing ecosystems and also enhancing and restoring them, in addition to a carbon removal benefit, is the fact that we actually can make them more resilient to a future climate if we do that well. And that's really important, because that then reduces the risk of us really losing out on these vital carbon sinks, which, as I said, are helping us out hugely. They're taking up, at the moment, about 50% of the CO2 we put into the atmosphere each year.
Great, thank you, guys. We are nearing the end of our launch event, and so I'm going to go around and ask everybody one more question, and that is, what would you love to see happen in the next year to help close the carbon removal gap? If you could keep your answers within a minute or two, that would be great. And we can start with Steve.
Oh, okay. Well, I'll have a go and then see what other people say. It's an interesting question. I think part of the analysis I was involved in more deeply in this report was the tracking of how much carbon dioxide removal is happening now. And while we've revised down the estimate of novel CDR, I think we see some really interesting things on the horizon. So one thing we didn't quite capture, because it's such fresh news, is the opening of the Mammoth plant in Iceland. We know that there's another big direct air capture and storage plant, Stratos, which is hopefully, if things go to plan, going to be up and running within the next 12 months. And we're seeing this really interesting proliferation of small scale, but really diverse and varied projects across a range of methods, with biochar sort of leading the charge in volume and distribution around the world. So I would really hope that we see that continue in the next 12 months. We see people trialing in responsible ways, new methods, so that we can do a bit of learning by doing, put the responsible policies in place to scale the ones that look good. But I think we're entering a really interesting time for new projects starting on the ground.
Great, thank you. Let's go to Will.
Yeah, for me, I think it's more ambition from the major emitters. So more ambition for them to rapidly cut emissions, including maybe a longer term perspective, right? The objective to achieve net negative CO2 emissions beyond 2050. Some countries are talking about that, but not very many are taking that longer view. Another thing is transparency. I mean, I alluded to this in the gap analysis. So really being clear, if countries can start to develop their plans a bit more clearly, if it's in the conventional CDR sectors, how much land can be afforested, at what rates, what are the expected risks of climate change and so forth that are going to come up, and that kind of information will be really crucial, I think, to assess progress.
Right, thank you. Inji, how about you?
Yeah, I think for me, looking at, particularly on the novel CDR, when we're in a situation when we're tracking up from, projects generating sometimes, 10 units of carbon dioxide removal and we need to be scaling up to billions, I think we equally need to be thinking about the solution on that scale too. And that includes this really systemic perspective that the Paris Agreement can give us. So that means getting the rules right on Article 6, including in the negotiations that are happening this week and next in Bonn. For instance, negotiators are discussing guidance on removals, including how to address reversals and whether that should lie with, for instance, the project developer or a host government ultimately. But then similarly to the broader calls I've heard for CDR, that we can't be putting all of our eggs in one basket, and the Paris Agreement also offers a number of other levers, some of which are very pertinent to CDR as well. For instance, Article 5 in terms of protecting and enhancing natural carbon sinks. We have Article 9 in general climate finance and Article 10 in terms of technology transfer. So I'd consider, I'd like to see that we utilize all those levers for the challenge ahead.
Great, thank you. Greg, how about you?
Yeah, I mean, my overall take, like in many climate things, is we're seeing lots of signs of progress, but challenges remain. And the signs of progress are often in the innovation indicators and how to address the challenges. I mean, for me, it's kind of three things. It's one, continue to support innovation around the world, supporting demonstrations, supporting early markets. Two, it's working out the monitoring, reporting, and verification, exploring continuously, but also starting to standardize to make transactions feasible and to make removals credible. And then finally, the most important is to create sustained expectations of demand for removed CO2, and governments have a key role to play there. And I think the final challenge I'd put on that is that ultimately, it's not just going to be about how many tons do we remove with these policies. It's also about how much do we learn in the process of doing that, because we need to find a way to get these technologies to improve as we deploy them, and importantly, to get the cost down as we deploy them. And if we're talking about removal costs that are in the hundreds of dollars per ton, that means we're talking about Matt's 7 to 9 gigatons a year, you know, on the order of $1 trillion a year. And so finding ways to make removals affordable through policy, through learning by doing, is going to be really crucial to making this whole effort sustainable in a policy and a political economy way.
Thank you. And Matt, your closing remarks.
Yeah, thanks. So I guess, I mean, for me, so what everybody said already, I think is very important. For example, Greg's MRV point and others. For me, I think there's a lot of momentum now in the sector, and it's up to the market mechanisms and also policymakers to sort of keep spurring that innovation. But if I take a bit of a medium to longer term perspective, I think the key issue is about clarity in terms of where nations and companies are headed in terms of their expectation of what role is CDR going to play in their net zero portfolio. And so on the company side, I think it's clarifying things with, for example, SBTi, as we talked about, but making it a top level item that companies should say what role CDR is going to play in their net zero strategies. And then on the country side, I mean, we had in the recent COP28 and the UAE consensus from the end of the global stocktake, carbon management, CCS, and CDR was explicitly mentioned for the first time. And I think that's a bit of a mixed bag, but what can really come out of this is more momentum for countries to say, what role will CDR play to explicitly set targets in terms of CDR vis-a-vis emission reductions, as Will pointed out. I think that would be a huge step forward in the policy and CDR space.
Amazing. Well, thank you. That is all we have time for today. Thank you for all the questions that were submitted. I'm sorry we didn't get around to answering all of them. Thank you to Steve, Will, Matt, Ingi, and Greg for sharing your work and knowledge with us. Thank you to the Smith Store for putting on this launch, and to all those behind the scenes who made this event possible, as well as all the other authors and research institutions involved with creating the report. I'd like to urge everyone here to download the full report. It will be available on stateofcdr.org, which is linked in the chat. And until next time, goodbye.